My dear students, in this video I am going to derive some mathematical standard results using induction principle. In mathematics we have some standard results, formula I mean, that results can be derived by using the mathematical induction principle. For example, consider this problem 1 square plus 2 square plus 3 square plus etc. plus n square equal to n into n plus 1 into 2n plus 1 by 6. This result you have known already. If you have studied this result, you are using this result, you have solved some problems in your lower class 10th standard. Now how we are going to find out how this result will come. This can be derived by the induction principle only. இந்த ரிசல்ட்டை வச்சு நீங்கள் 10th சில கணக்குகள் போட்டிருப்பீங்க, சம்மேஷன் ஆஃப் சீரீஸ் இந்த முறையில் அரித்மெட்டிக் சீரீஸ். இப்போ இதில் ஸ்கொயர்ஸ் ஆஃப் த n நேச்சுரல் நம்பர்ஸ்க்கு ஃபார்முலா இதை எப்படி நம்ம இண்டக்ஷன் பிரின்சிபலில் இது எப்படி வந்ததுன்னு பார்க்க போகிறோம். அதுக்கு நம்ம யூஸ்வலாக என்ன செய்வோம், த கிவன் ரிசல்ட் கேன் பி இது ஹேஸ் பி ஆஃப் n. இதை வந்து பி ஆஃப் n வச்சுக்கணும். The given result is considered as P of n. P of n equal to 1 square plus 2 square plus 3 square etc. plus n square. Left hand side, right hand side is n into n plus 1 into 2n plus 1 6. By the induction principle, you know, first initial step, we have to prove that the result is true for n equal to 1. First step, we have to prove that the result is true for n equal to 1. n is any natural number, positive integer I mean. That is p of 1 equal to left hand side, p of 1, if you put n equal to 1 square, 1 square is no 1. On the right hand side, p of 1 equal to 1, n is 1 into 1 plus 1, n is 1 into 2n plus 1, 2 into 1 plus 1 by 6. That is equal to 1 into 1 plus 1, 2 into 2 into 1, 2 plus 1, 3 by 6. You know, 2 into 3, 6, 6 into 1, 6, 6 by 6, that is equal to 1. So right hand side, left hand side is 1 and right hand side is also 1. Therefore, LHS is equal to RHS. Therefore, the result is true for n equal to 1. Next, initial induction step. We assume that the result is true for n equal to k. இதுக்கப்புறம் செகண்ட் ஸ்டெப்ல நம்ம என்ன பண்ணுவோம்னா கேக்கு இந்த ரிசல்ட் ட்ரூன்னு வச்சுக்கிட்டு கே பிளஸ் ஒன்னுக்கு ரிசல்ட் ட்ரூன்னு ப்ரூவ் பண்ணிட்டா சக்சஸிவ் கே வேல்யூஸ் லீட்ஸ் டு த நேச்சுரல் நம்பர் n. ஓகே, இப்போ we assume that the result is second step. We assume that next we assume that the result is true for n equal to k. Induction step. What is p of k? 1 square plus 2 square plus 3 square plus etc. plus k square equal to right hand side instead of n we have to replace k. That is k into k plus 1 into 2k plus 1 by 6. This is true. P of k, we assume that the result is true for n equal to k, and we have to prove that the result is true for n equal to k plus 1. We have to prove that the result is true for n equal to k plus 1. That is, what is p of k plus 1? P of k plus 1 equal to 1 square plus 2 square plus 3 square plus etc. plus k square up to k. Next, k plus 1 square. See, this is your left hand side. This left hand side is equal to what we have to prove. We will see on the right hand side. Okay? Now, we have to prove that the result is true for n equal to k plus 1. For that, left hand side is this 1 square plus 2 square plus 3 square plus k square plus k plus 1. But what we have to prove? P of k plus 1, right hand side of P of k plus 1 equal to n equal to k plus 1. K plus 1 into k plus 1 plus 1 into 2 into k plus 1 plus 1 by 6. That is equal to k plus 1 into k plus 1 plus 1 is k plus 2 into 2 into k, 2k plus 2 plus 1, 2k plus 3 by 6. This is what we have to prove. So, P of k, right hand side should be proved. If you prove this step, we will get the answer. Up to that, in this left hand side, 1 square plus 2 square plus 3 square up to this k square, you can get P of k. So, P of k plus 1 equal to, left hand side is P of k plus k plus 1 whole square. Because up to this, you know P of k. You know what is P of k? The result is already assumed that the result is true for P of k. That is, P of k is this, k into k plus 1 into 2k plus 1 by 6. For k, P of k, the result is true. For k plus 1, we have to prove the result is true. We have to prove that the result is true for n equal to k plus 1. For that, P of k plus k plus 1, step k plus 1 square. So, by simplifying, okay. Now, P of k plus 1, right hand side is P of k is k into k plus 1 into k plus 1 by 6 plus k plus 1 square. You take 6 as common LCM. You will get k into k plus 1 into 2k plus 1 plus, if you take a 6 as LCM, 6 into k plus 1 whole square. Common LCM, if you take 6, you will get this. Okay. Now, in the numerator, k plus 1 is a common term. You will take common as k plus 1. You will get k into 2k plus 1 plus 6 into k plus 1. Okay. If you take k plus 1 in these two terms as common terms, you will get k plus 1 in. If you take common, k into 2k plus 1 plus 6 into k plus 1 by 6. That is equal to k plus 1 into 2k square plus k into 1k plus 6k plus 6 into 1 6, the whole divided by 6. Okay. Now we have k plus 1 equal to k plus 1 into, this is 2k square plus 7k plus 6. 2k square plus 7k plus 6, the whole divided by 6. 2k square plus 7k plus 6 by 6. This, you can factorize 2k square plus 7k plus 6. If you multiply these two, you will get 12. 2 6 are 12. You split the 12 into two terms, two factors. 4k plus 3k. 4 plus 3 7. 4 into 3 12. So what do you get? P of k plus 1 is k plus 1 into 2k square plus 4k plus 3k, 7k plus 6. 7k is 4k plus 3k. And this is equal to k plus 1 into, if you take 2k common in these two terms, you will get 2k into k plus 2. If you take 3 common, you will get k plus 2. If you take 3 in these two terms common, if you get 2k common in these first two terms, you will get 2k into k plus 2. And if you take 3 as a common term, you will get k plus 2. Okay. By 6. if you take these two factors, you will get k plus 1 into, if you take k plus 2 in these two terms and a common term, you will get k plus 2 into 2k plus 3. If you take 2k plus 2 common answer, 2k plus 3 equal to by 6. K plus 1 into k plus 2 into 2k plus 3 divided by 6. You will get the right answer required, right answer steps you will derive, and therefore the result is true for n equal to k plus 1 also. Assuming the result is true for n equal to k, and we proved that the result is true for n equal to k plus 1. For n equal to k plus 1, p of k plus 1 is k plus 1 into k plus 2 into 2k plus 3 by 6 you will get. Therefore, the result is true for n equal to k plus 1. Okay? Now, we proved that the result is true for n equal to k plus 1. Therefore, the result is true for all n natural number, positive integer n. For all positive integer n, the result is true for all positive integer n. Hence, the result is proved. Hence, the result is proved by induction principle. That's all about the problem. Okay? Next result, sum of the cube of the n natural numbers. Sum to n cube of the natural numbers. What is the result? N into n plus 1 by 2 the whole square is the result. That is also, you have solved some problems using this result in your lower classes. So that is 1 cube plus 2 cube plus 3 cube is equal plus n cube equal to n into n plus 1 by 2 the whole square. This is some standard mathematical result. This result, how to prove, we will see by the induction principle. You consider the required result as P of n. Now, we have to prove that the result is true for n equal to 1. First step, we have to prove that the result is true for n equal to 1. That is P of 1. Left hand side, 1 cube, that is equal to 1. This is your left hand side. Right hand side, 1 into 1 plus 1 by 2, the whole square. That is equal to 1 into 2 by 2, the whole square. That is equal to 1 into 2 into 2, 2 by 2, whole square is 4 by 4, that is equal to 1. 2 square is 4, denominator 2 square is 4, 4 by 4, that is R1, 4, 4 cancel, 1 square is 1, whatever it may be. And that is 1, therefore the result is true for n equal to 1. Result is true for, result is proved for n equal to 1. Next induction step, we have to assume that the result is true for n equal to k. Next step, we assume that the result is true for n equal to k. Now, we assume that the result is true for n equal to k, that is P of k. K to the result 1 minus vechikrom, that is 2 cube, 3 cube, plus etc. plus k cube equal to k into k plus 1 by 2, the whole square. In the result true nu vechikrom. K into k plus 1 by 2, the whole square is true for k n equal to k. Induction step says that the result is, we have to prove the result is true for n equal to k plus 1. K is true, no? We have to prove that, induction principle. We have to prove that the result is true for, the given result is true for n equal to k plus 1. What is on the right hand side, left hand side? Result 1 cube, 1 cube plus 2 cube plus 3q, etc. plus kq plus we have to prove for k plus 1. Therefore, next step k plus 1q is equal to what we have to prove. Instead of k, we have to put k plus 1. Right hand side is n for k plus 1 into k plus 1 plus 1. K plus 1 is k plus 2 by 2 the whole square. So the left hand side is k plus 1 into right hand side k plus 1 into k plus 2, k plus 1 plus 1 is k plus 2 by 2 the whole square. That's what you have to do. Is it not? This is square. K plus 1 into k plus 2 by 2 the whole square we have to prove, which is on the right hand side. Left hand side, up to this LHS, up to this P of k, up to this P of k. What is P of k? K into k plus 1 by 2 the whole square. This is P of k plus 1 whole cube. Another step. This is your left hand side. Right hand side is this k plus 1 into k plus 2 by 2 the whole square. See, we will get this right hand side answer by simplifying this. Okay? See, is this left hand side P of k plus 1 is k into k plus 1 whole square by 2. By taking LCM, this is k square into k plus 1 whole square by 4. By simplifying this k square into k plus 1 whole square by 4 plus k plus 1 whole cube. Okay. By taking 4 as LCM, you will get k square into k plus 1 whole square in plus k plus 1 whole cube. From this step, you can find k plus 1 common out. K plus 1 whole square, we can take a common term in both the terms. We can find k plus 1 whole square as a common term. K plus 1 whole square is a common. K plus 1 whole square is k plus 1 whole cube, k plus 1 square. So as etc., you get k square. This is one k plus 1 whole square we are taking as a common term, we will get only k plus 1. So k, by taking LCM 4, this 4 will come here. Multiplication. This 4, by taking LCM, this is 4 into k plus 1 whole cube. So that is k plus 1 into 1, 4 is there. Okay? By the common LCM 4. By taking 4 as a common denominator, you multiply the second term by 4 also. Therefore, 4 into k plus 1. So what do you get? I am writing here P of k plus 1 equal to k plus 1 whole square, k square plus 4k plus 4, k square plus 4k plus 4 by 4. This is k plus 1 whole square. K square plus 4k plus 4 is k plus 2 whole square. This is nothing but this is k plus 2 the whole square. K square plus 2 into 2, 4k plus 2 square 4. So this is k square plus 4k plus 4 is k plus 2 whole square, you know, by 4. Now we can, taking square as a common term, both the numerator and denominator, k plus 1 into k plus 2 by 2 the whole square. K plus 1 into k plus 2 by 2 the whole square. K plus 1 by k plus 2, k plus 1 by k plus 2 by 2 the whole square, which is equal to our required right hand side answer, which is equal to RHS. So LHS equal to RHS. Therefore, this term is proved for n equal to k plus 1. Therefore, the result is true for, now we will see, therefore the result is true for n equal to k plus 1 and hence the result is true for all n. That's all our conclusion step. So after proving this, assuming the result is true for n equal to k and proving that the result is true for n equal to k plus 1, then we conclude that the result is true for n equal to k plus 1 and hence the result is true for all natural n. Therefore the result is true for n equal to k plus 1. Assuming the result is true for n equal to k, we proved that the result is true for n equal to k plus 1. Hence the given result is true for all natural n. That's all about the bookwork, and thereby I conclude my video, and we will continue the remaining problems in our next video. Thank you.